Tonight we're going to look at graphing linear inequalities in two variables. Okay? Graphing linear inequalities in two variables is very much the same as graphing equations in two variables. Recall the standard form of the equation. This is ax plus by equals c, where a and b are the coefficients of the variables and c is a constant. This is the same as for the inequality, where instead of equal, we have less than or equal to, greater than or equal to. We treat these just like an equation, but remember the special rule for the inequality. Okay? When we rewrite in slope-intercept form, we may need to solve for y, just like an equation, but if we multiply or divide by a negative number, we have to flip the inequality sign. Okay. Let's take, for example, x plus y is less than or equal to 6. Okay. We want to rewrite this in slope-intercept form, so we need to move the x to the other side of the equation. So we subtract x from both sides, and we end up with y is less than or equal to negative x plus 6. Okay. This is slope-intercept form because the slope is the coefficient of the x term, and 6 is the y-intercept. And we're talking about the equation y equals negative x plus 6, and that is the boundary line. So we're going to graph that equation. So we find the y-intercept, which is at 0, 6, and then from there we follow the slope. We go down 1 and 1 to the right. Okay, because there's a negative slope of 1. Okay. Then we simply connect the dots, and that is our line. Now for the inequality, we have to consider which side of the line satisfies the inequality. So we're going to test the point 0, 0. Okay? When we plug it in, we get 0 is less than or equal to 6. This is true, so that is the side of the line that we want to shade in. And then remember, for boundary lines, if we have less than or equal to, greater than or equal to, we use the solid line. And if we have simply less than or greater than, we use a dashed line.